Today we're live with Syed Karim, who is the founder and CEO of Outernet, which is a project planning to bring the information of internet to everybody. Syed, thanks for joining us today.
Thanks for having me.
So why don't you go ahead and get us started? What is exactly the concept of Outernet?
So the whole notion of Outernet is to bring valuable information that now is, oftentimes primarily found on the internet, and make it accessible to places that don't have, for whatever reason, access to the internet. So we essentially, what we're doing, video or TV or radio, and applying it to a data service. Everything now, as far as content, can be digitized and turned into packets. And so what we do is just make offline versions of content and then go ahead and broadcast it, as of right now, over 6-7 different satellites. And we hope to go ahead and increase that both from a content delivery perspective and also from different frequencies all over the world.
Very cool. I was just telling you off air that I thought Outernet was one of the coolest projects we've highlighted on here, and that's no offense to our other cool projects. And I think it's something that has been around for a bit. But tell us where how it's already being used, and how do you want it to be used, in the near future, as well as what reactions and use cases have you expected, or do you really hope to come true with it, and that you maybe pitch to investors or prospective investors?
Sure. So let's see. There's a lot in there. So remind me if I miss anything. So as far as how we would like for it to be used, so naturally we'd like to. We consider this as almost like a mashup, right? So it's a mashup of BitTorrent and Reddit, a little bit of YouTube thrown in there. And so the reason I use those as examples is, BitTorrent essentially as kind of a downloading of content service, and kind of emphasize the whole notion that it is a unidirectional system as of right now. The real reason that we exist is to solve the information access problem. And so one way to do that is by creating space-based internet that's accessible everywhere. But the problem with that is fundamentally a cost issue. And the other thing that we're doing is I'm sorry, I lost my train of thought. So the how it's going to be used. And so because we want to keep this as decentralized as possible and essentially not have this a gatekeeper service like, let's say, like normal traditional media, what we're doing is planning on opening up essentially a self-service application that allows anyone to be able to say, hey, I think this is important, that the world should be able to aware of it, and kind of upload relevant and important information, and then broadcast it over our network. So essentially what we do is we operate where anyone to be able to contribute to it. So that will actually be available in about a month. Up until for the past about year that we've been operating, we've really been focusing on getting all of our back-end and front-end systems, delivering hardware, making sure firmware works, all that stuff. And in about a month or so is when we're going to be really releasing, saying, hey, this is how anyone can interact. This is what you need to be able to build your own receiver. This is what you need if you want to interface with, and working towards for the past, essentially the past year. As far as what has been kind of the pitch that we've been making, both to customers, to investors, that there's really no reason that this should not exist. And so the whole notion of there being a basic level of information accessible to everyone, to a large degree we have a similar platform that exists, in TV, radio, and also in GPS. We already have similar types of broadcast data service. And so essentially what we're saying is that there's more information that should be accessible to everyone, and this is one way to do it.
So Syed, what is sort of the philosophy behind this project for you? Why did you consider it so important to get this information out to everyone?
Why? So there's two sides to that. One could be completely cynical, and one could be really more, much more idealistic. And what really drives me is the nature of the problem to be solved, and solving a problem that affects far more people then it doesn't. So we say we tend to, based on where we all come from, fairly certain that everyone's grew up in the States, and naturally our network infrastructure is maybe not the best in the world, but still much better than it is in a lot of places. Actually, much better than it is in the vast majority of the world. And so if we're saying idealistically, it's like, hey, this is a pain point, this is a problem to be solved for billions of people. That's really where it came to do, is basically information access. If we're talking about the global economy, the modern economy, it's fundamentally related to access to information, access to education, skills being developed as a result of all that. And what really separates, the only thing that separates people nowadays is really being able to acquire skills or gain opportunity as a result of access to a very inexpensive, relatively inexpensive and fast way to be able to solve the divide when it comes to information access. And note that I'm not using the word internet access. Naturally, that is something that we want to move towards at some point, but instead of waiting 5 or 10 years for proprietary rocket ships or satellite factories to be developed, this is something we can do almost instantaneously, as we've shown over the past few months. And then the other side of it is like, hey, what we get over and over again is what we hear is like, is this is a nonprofit, this is a charity? It's like, no, it's not at all. I mean, ultimately, we're operating a broadcast service, and so no one really kind of questions, oh, is CNN a charity? They offer free information, or is your local radio stations, are they charities? They operate free information and entertainment services. So ultimately, I more often than not, and very lately, I've been getting annoyed by that, because to me it just seems like a stupid question, because there are alternatives that solve similar problems, or at least approach it in the same way. And and essentially what we're saying is that we can solve a problem at scale and still do good and do well at the same time. So that's kind of the both sides of it. Is what really drives myself and my team is naturally to be able to provide an information service to everyone, to be able to solve those problems. But ultimately, there has to be some kind of a way to scale this from a financial perspective, and there's a perfectly justifiable way to do so.
So Syed, you talk a lot about increasing the availability of information, and it seems like that is probably one of your core values here. Is there another secondary factor that you're considering? Is it privacy? I mean, is there something else here that's driving what you guys are doing?
Sure. So privacy is definitely one. There's especially when we're talking about the reasons why information doesn't exist in certain places. That is generally related to three factors. So one is infrastructure, just that it doesn't exist. That's actually kind of a half reason. Internet access actually exists everywhere in the world. The only thing that prevents anyone from gaining access to the internet is really cost, and it's really a financial barrier. So even in places where you can be in the middle of the Sahara and say, oh well, infrastructure doesn't exist. Actually, space-based assets do exist and do work in everywhere, except for in some cases the poles. Actually, even Iridium works there. So it's really not a matter of whether it exists or not. It's just a matter of, do you have the money to be able to pay for it? And so then we're really going down to well, what are the two reasons that certain types of information aren't accessible? And so one is really a financial or economic barrier, and the other one is let's see. It really has to do with more of a political barrier when it comes to access to information. So in some places, in actually huge swaths of the world, there's just different filters or means to be able to prevent access to certain types of information, either changing it or just blocking it completely. And one of the things, the way to solve for that is to create a broadcast system where people can opt into receiving without having to leave a trail or some kind of breadcrumbs behind as far as what their activities when it comes to the consumption of information are. So what we're guaranteeing from one of the benefits to the broadcast system is that it guarantees the anonymity of consumption. When you're reading up a newspaper, no one actually knows what it is that you're doing, and by and large, it doesn't matter. It's not like it's an experience that you have to hold very private. But it's also one of those things. Well, why should anyone have the right to know? And so that's one of the things that we do get to guarantee from the way that this system's been designed.
And speaking of the design of the system, how has it evolved over time? What was the shell of the idea that this started, and what was the structure and level of centralization, and how did it change? Again, I have a tendency to ask too many questions in one, so I guess we'll just stick with the main one of, how has it evolved? How has it changed?
Sure. So, I mean, the one thing that hasn't changed is, over the past year or so, we announced what we were doing, a little over a year ago, and really got into sketching out exactly our plan of attack almost a year precisely. And the problem and the general solution has not changed. The problem we've identified is access to information. So what is the fastest way to be able to create, the equivalent of humanities public library, to be able to create a digital version of the Library of Alexandria that's accessible to everyone. So one of the first things we did was saying, hey, what we're really not trying to do is create the internet for everyone. That's a problem left to Google. That's a problem left to Facebook or Elon Musk or whoever it is. Let them solve it in the next 5 to 10 years. As a little side note is that Bill Gates wanted to solve that too, about 10 years ago, and he said he didn't have enough money to solve it, or at least didn't want to spend the money to do so. So we wanted to be able to tackle a problem that we thought was important, and also that we could do, something that we could solve pretty quickly. And so that's one way is that the problem has been focused on access to information, not access to the internet. And then as far as the things that have changed, so naturally when now you start getting into execution, then it's a matter of, okay, well, should we use small satellites? Should we use large satellites? Should we use this kind of protocol versus the other standard? Should we use a Raspberry Pi or a big old black? And then you start getting into kind of the minutia of what it takes to actually get a plan rolling, and to solve problems in the field. And so that has changed a little bit here and there, but more or less it stayed on the same trajectory. What has changed is saying that, okay, well, maybe this isn't one decision from previous decision is not the most cost-effective, or it's not the most expeditious manner for us to be able to roll out. So those are the things, whether it's it's geostationary or LEO or things of those nature, really quite technical decisions. But that's what has maybe modified a bit in the past year.
Syed, you talked a little bit about scalability and about sort of bringing this project to everyone, and obviously it takes some cash. Obviously, I know Outernet has plans to broadcast for free, but is there sort of a monetization model that's going to support your continued expansion?
Absolutely. So even though we aren't long-term, at least, wholly focused on hardware, we have a different kind of a rollout strategy, but we are building our own hardware now. And actually, when you build something and you sell it, a physical device, then you get to benefit from margin. So that's something, and the benefit to having a hardware business is that from a cash flow perspective, it works pretty well. You sell something, you get a piece of it, and then you sell some more stuff and market it more, and it's a nice happy cycle. The other way, as you sell more devices, that means your audience increases in size, and as an audience increases in size, some people want to be able to reach that audience, and so we don't have an advertising model. What we have is a sponsorship model. So regardless of what it is that your content is, whether if it happens to be messaging about a product, or it happens to be your podcast, or maybe you want to be able to sponsor and information that you think is important, let's say like Wikipedia or weather or OpenStreetMaps. That's something that you can do over our system. So that's a model right now that has to do with paid content, essentially content sponsorship. And then, of course, we're opening up the platform, and so we're not entirely sure what's going to happen. Essentially, saying that here, this is how you build. This is how you build hardware. This is the software that you need. It's freeware. Most of it is open source, and this is how you bounce stuff off the satellites. And we'll let developers figure out ways to be able to build applications that work in the kind of offline environment that we have. So the third component is kind of a wild card, and we'll just kind of let the market take over there.
So you mentioned a few minutes ago this idea of a digital library of Alexandria, right, where all this content is available for people to consume. How do you guys go through that selection process? How do you determine what is actually going to be in your library?
So number one is that we personally, Outernet doesn't want to be the ones to determine that. We would like to have such a flow of information that it's really up to the user to determine what it is that they want. And it's almost like kind of filtering based on interest. And so whether that interest is language, whether it's geography, whether it's topic area, category, that's something that you kind of filter on the receiver itself. So your receiver, the analogy on a radio is not that far off. Let's call it like a mashup of a regular FM receiver and Amazon.com. And what I mean by that is, so you're tuned into the frequency like an FM radio, and then once you have that, you're just getting a whole bunch of information. So like you've gone to Amazon, and you've said, I want to buy a chair. And then it's a matter of, okay, well, you have 17 million results. What kind of a chair? You want a wooden chair? You want a rocking chair? You want a chair that is Amazon Prime? You want at something that's handcrafted, or maybe at a certain dollar point. So you get to do that faceted search based on that criteria, and that's really what the user experience is heading towards. So we just go ahead and give it a fire hose of information and let the user determine what it is that they want to keep or throw out. So naturally, when it comes to the uplinking or the uploading of information, there's a small segment of the capacity that staff will basically create a kind of like a daily newsletter around, but the vast majority of it we would really like the world at large to determine as what is important and useful.
So Syed, you also mentioned that basically the software for receiving broadcasts from Outernet is open source. Are there any projects or developers out there building anything of note to you as far as applications of the software?
No, so I also want to be very clear and transparent about the open source. So the majority of it is open source, and you can go ahead and check it out. GitHub's Outernet, is it Outernet-project on GitHub is what you would search for. And then there is a small piece of it, which is our data casting client. That is free, but that part is not open source. So that aside, it still allows you to build hardware and also to build applications. Being that we've been kind of huddled around making sure everything works the way that they need to, and also creating some documentation for people to build their own applications, there hasn't been a lot of actually I'm almost certain that there's been no contributions, maybe a few, maybe 4 or 5 pull requests, fixing bugs and the such for our Raspberry Pi image. But we expect that to change once we announce exactly the fact that we are globally accessible. We're available on these different satellites, and and we point to our repos to be able to say, hey, fork it, change it, figure out some way to take advantage of it.
Cool. And I know you went into a little bit about the hardware earlier, and that was one of the parts that interested me the most. Now, let's say that I'm wanting to run to the store right now and buy the equipment to build this hardware. What would one need, and is this something that you're planning to create as a commercial product in the future?
Oh, absolutely. So we're releasing a commercial product very soon. It's a DVB-S receiver that has a integrated Wi-Fi radio, which we turn into an access point. So by and large, what this receiver is a fairly low-cost system on a chip, as well as some internal storage, some USB storage, memory and all that, and then a DVB-S tuner and a Wi-Fi radio. So you smack that all together, and you can describe it in many ways. I like to describe it as essentially a Wi-Fi access point that has a integrated satellite tuner. You can just describe it the inverse of that as well. So basically, what it does is you hook up a external dish to it, tune into the right frequency, and then download all the content that's being delivered over the course of that day, or for however long you have it. That's something we have 2 models right now to be able to either build it yourself or actually just buy it. So in about a month or so, you'll be able to just buy something that works out of the box. It has the software that's flashed, and then it's just a matter of pointing your dish and hooking it up, and then presto, it's downloading. The other way to be able to do it is as long as you have a Linux-compatible DVB-S tuner. And so this is essentially the little piece of component that if you've ever seen a satellite dish, what's kind of funny is that in the U.S. there's a completely different standard that is dominant versus the rest of the world. Basically, everywhere in the U.S. is direct broadcast satellite service, DirecTV and Dish TV. Everywhere else is DVB-S, and so it's slightly different in that different components are involved. But ultimately, you have an LNB which receives the signal at KU band. KU band is roughly like 10 gigahertz, 12 gigahertz. Then there's a little nub on that dish. It's called an LNB. That's something that down converts that signal into L-band, and L-band is roughly between 950 megahertz and 2150 megahertz, and that is what's fed to the receiver. That L-band. The L-band, there's a F connector, and so as the signal travels to the F connector, it goes to a demodulator, and these are generally pretty inexpensive demodulator chips because of the fact that everyone in the world uses this standard, the DVB-S standard. And so from there, the signal is turned from that transport stream, originally said transport stream, comes back down over the satellite, and it's demodulated into data. once it's in data, then it gets passed on to the SOS. Our software, the data casting client, turns it into usable files. And then once the usable files are just kind of stuffed into the onboard storage, 64 gig flash drive, that's when you can start interacting with it no differently from if you were at the airport and you see that captive portal. So at that point, when you turn on the receiver, whether it's a Raspberry Pi or whether it's our own device called a Pillar, you see a Wi-Fi. If you're in the vicinity, you'll see a Wi-Fi access point called Outernet. It's an open network. You associate with that network, and you'll immediately be led to a particular website that'll say librarian.outernet. From there, you'll see all the content that's been downloaded. Sometimes there may be offline applications. There'll be some Khan Academy videos. Essentially, at that point, it just goes into the content experience, which, like I said, we want to be a little bit more hands-off again, since we want to let the world kind of determine that. But that's exactly how the hardware operates. Whether it's you build it yourself or you buy it from us.
That's awesome. Just listening to you talk about the hardware is fascinating. I think we could probably dedicate an entire show to just hardware hacking and building. So thanks for that.
Sure.
Let's talk a little more broadly about the overall platform. We talked a little bit about open source. We talked about the hardware. What are some issues that you have right now that you think the community you'd like to see contributions from the community towards? Whether that's hardware, software, business strategy, whatever that may be. What are some of the gaps?
So I'd say the real gap is in software, in the application layer. So the user interface is called Librarian. That's something that it would be great to have local versions or special use cases. At the end of the day, you can actually see that entire code base on GitHub, and if there's the way the thing you should have in your mind is that each one of these hardware instances is really just a web server that accesses content in a local file system. And so if you can think of some interesting applications and user interfaces for that, whether it's whether it's a mapping application, or it's weather, or commodity prices, or Bitcoin updating, throughout the whole world without having an internet connection, that would be outstanding for people to kind of develop applications or develop different kinds of interfaces. That we wholly support, and it's one of those things where if you have something, like we have no problems with just like sending it over the air to see how it works. You can also replicate it local host, but we're happy to send it over the air as well.
Syed, one of the concerns expressed both kind of implicitly and explicitly at points is that of censorship. Obviously, with broadcasting, there's not really a whole lot of sort of that control over what people can receive to their various receiving devices. Is this something that concerns you? Is this something that Outernet you think is sort of almost purposefully designed to work around? Sure.
So it was a consideration when everything was being designed in the early days. It was basically the two constraints, like I mentioned before, when it comes to access information, are economic and then to a certain degree political. And so what kind of a system best addresses both of them at the same time? Naturally, there are all kinds of ways when it comes to internet access. There's Tor and derivatives of that. But they are all kind of contingent upon access to the internet in the first place. And so if you're really trying to create a globally accessible system that really addresses the economic barrier or financial barrier, then you have to actually get away from the internet. That's just not going to work. It's not going to scale to the speed that really want to. Now, granted, the argument against what we're doing is that, oh, well, you still need receivers out in the field. Well, once we start supporting more and more types of devices, when basically where if you wanted to, it's like we gave you instructions on how to build and manufacture these receivers, well then essentially we're seeding an ecosystem that's not that dissimilar from Android, where we're just the ones who are maintaining the software, making sure that works, but everyone else is building their own products and making sure that it gets distributed even the most remote places. And so that goes again to talk about when it comes to anti-censorship, is that if we want to be able to get in the most difficult places, whether from just purely logistics or from a political reasons, a political perspective, is that we're not going to be able to address that supply chain. And so if we really want to go places where information is limited, then we're going to have to enable people to be able to address those problems locally, because we're not going to be able to solve it.
So talk a little bit about the future, do you think that there's a situation where if you're disseminating information, right, you're making this information widely available to people, do you envision a sort of a future where maybe governments or powers that be are going to try to prevent this from working? And as a second part to that, what are some defense mechanisms and things you're thinking about to protect against that?
Sure. So that's absolutely something that we're considering. We can't. The reality of just to be able to bring something out to the world is that we can't dwell too much on the what ifs. You essentially just have to ship the product and then see how things react. I'm fairly certain that it's not going to happen, right off the bat. But it will happen, especially as more and more, like I said, local shops start building their own receivers in places where, it would be frowned on. And so then what happens is the natural progression, and it has happened in the satellite TV industry, is there are certain jurisdictions who just try to jam satellites. That's very possible to do, especially with a conventional signal. And then what we have to do next is say, okay, well, and we do have basically fail-safes or next steps, if-thens. There are things that we can do to be able to move to different types of infrastructure, satellite infrastructure. There are other types of modulation and coding schemes that we can use. One of the things, really what it comes down to is the best defense. It unfortunately ends up being that we have to switch to new types of signaling and also require new types of hardware. But ultimately, as long as you give everyone kind of the option and let them know where things are transitioning, then it's possible. So I was a little vague in all of that, and what I mean by that is that, so for example, if we were to start with regular TV, KU band broadcasting, and then that transponder gets jammed, and then our satellite operator says, okay, well, we need to either turn you off or you have to go to another transponder. Say, okay, fine. Well, maybe we'll go ahead and move all the educational material to this particular transponder, and then move some of the more controversial content to something that is a little bit more robust in the way that in its RF characteristics. What I mean by that is, like, we can do things like spread spectrum, and so spread spectrum is below the sound floor, and so it is difficult, if not impossible. I say impossible loosely, to jam because it's below the noise floor. And so what's an example of something that's difficult to jam and it operates the same way? It's like GPS. GPS is actually a heavily spread signal. It exists everywhere, and it's an infrastructure that's always in motion. So that's a great example of what we could move towards if we start seeing difficulties with certain jurisdictions, confronting us when it comes to content delivery. And so there is the path forward there is a path forward that's been designed. We would absolutely love to not have to go cat and mouse, but there is a way to be able to solve for those things.
Are there any other projects or decentralized technologies out there that you're looking forward to working with, or that would be helpful to sort of your distribution? Obviously, we've talked to guests like Jeff Garzik on the show before, who's working on the BitSat project of distributing like multiple cheaply made satellites into space. And it sounds like something very related to sort of this broadcasting issue. But are there any other projects out there that you're particularly interested in or hoping to integrate with Outernet?
So no, and only because we're really addressing this. We have a very specific use case. Now granted, what the Jeff Garz is doing is related. I've been very confused by that approach. I guess I don't fully understand the problem solution over there. Only because I think he'd actually be better off using geostationary satellites and just broadcasting that way. We're in the development of 3 of our own CubeSats, so it's not like they don't have their place. It's just that when it comes to anything in space, utility is all based on one thing, and that's power. And power everywhere, especially specifically when you're dealing with solar, is a function of size. You can't get around that. And with a CubeSat, there's only so much that you can do. And so power is directly related to your communications capacity. And if you're really trying to deliver and from a broadcast perspective, be completely accessible to the world at, I think the blockchain is something like 1 meg per second now, if I'm not mistaken. You can only do so much with small sats. You're much better off, if not going to larger satellites, which cost a lot more, or just going to geostationary. So from that perspective, to answer specifically that comment, that's something that we can actually replicate. We've been doing the blockchain right now. It's just a matter of, hey, does anyone want to build something on the receive side? As far as some other platforms we want to build against, it's to our perspective is like we really want to see the market and allow people to build applications against. Other infrastructure, we're already, working with, L-band operators, KU band, C-band. So we're where we want to be from a broadcast infrastructure, and then of course, building our own assets that go into space. Would it be ideal if we could also work with something like Loon? Yeah, it would be. It would be great. I think it would really solve problems or address it in a different way. But that's just a matter of having the right conversation with the right people and making sure everyone's in alignment. But once you get away from infrastructure, then it's a matter of, okay, well, let the world take over. We don't want to stand in anyone's way.
All right, Syed, we're coming to a close here. But before we go, why don't you share where can people find you on social media? What links do you want to share? And do you have any things that you want to plug before people end the show?
Sure. So if you just check Outernet, if you search for that, you'll come up, with our site, which will be changing in a few weeks. If you want to learn, probably the most in-depth place of information, which we've authored, is on the Indiegogo campaign. Let's see, probably the best way is just to do IGG space Outernet in Google search, and that'll come up, Indiegogo Outernet. And then on Twitter, our handle is Outernet4all, F-O-R-A-L-L. Facebook's the same, facebook.com/Outernet4all. And then, if you ever want to reach out to me, I'm at Syed Karim, and pretty accessible over Twitter, email, anything of the sort.
All right, Syed, this is a fascinating project, and we really appreciate you taking time out of your day to join us today and share what you're working on with our listeners. So thanks for joining us.
Thanks for your time.
Absolutely.